Okay, everybody, today we're going to continue our uh, delving into rotations and symmetry. And I was doing a little more thinking about mathematical symmetry and what that means. And I pulled up a really good quote, or I found a really good quote that broke it down, I think, quite well. And it said, in general, an object is symmetric when it is invariant under some kind of transformation. With polygons like we're dealing with, that's really nice because basically if you can pull out a shape and do whatever transformation and fit it over top of something else, like another shape that they're asking if it's symmetrical or not. If it fits that shape, whether you rotate it, mirror it, flip it, whatever, you know it's symmetrical. You might not know exactly the operation to get there, but it's not too hard to identify whether something has some sort of symmetry. It is a little tougher to identify what that symmetry is and what operation to do. So rotation around a vertex is kind of the last piece of symmetry that we're probably going to get into. I think maybe we'll see. And most of the rotational symmetry that we've seen has been around the center point of a polygon. So you take the center of some shape and you rotate it, like a star or those fractals that you guys have posted. Now we're going to look at rotation around a vertex. So I guess this is something we should talk about first. Often you'll see a triangle ABC and triangle, and it's like A prime, B prime, C prime, or like A1, B1, C1, or A2, B2, C2. You'll notice these have like multiple primes, like a apostrophe apostrophe, and then A, and then triple apostrophe. So the shape without any of those is the original, and then the ones coming after that are rotations or transformations. In this case, they're rotations, but they could be any transformation. So it's a naming convention that, excuse me, that helps show that this shape, A prime, B prime, C prime, is the same shape as ABC, but in a different orientation, or after it's been transformed somehow. So let's do a couple examples to show you what these might look like. So if our question is rotate triangle ABC around point C 90 degrees clockwise, and I want to point out to you guys that a lot of people have sent me messages saying like, oh, I don't have graph paper, or I don't have a protractor, or something like that. Don't worry about that. Try it anyways. Do it freehand. I'm not really testing you guys on how neat or precise uh, your work is, especially not online. Maybe in person I would do that, but then I could like give you guys protractors to work with. I'm testing more. Do you know what operation you should be doing? Do you know how to go about doing this operation? If you had a protractor, could you do it specifically? I'm not testing you on the protractor use and all that kind of stuff. So I'll show you how I do it, and I do it purely freehand. But it demonstrates that I have an idea of how to do this. So if we're rotating around a point, we're going to say point C, right? That's going to be our rotation point. We're basically going to take this whole triangle, and since we're going clockwise, remember clockwise going that way, we're going to take this whole triangle and just kind of shift it like that. Okay. So we take our let's go CB. That's going to be the line that we're going to take. Let's say this is, if you kind of tilt your head to the left, you can imagine that this is kind of your 0 degrees. And if you go 90 degrees this way, your line is going to kind of go this direction, right? So if we have 90 degrees there. And if we go 90 more degrees, we would have something that goes exactly opposite of C to B. And again, these lines aren't perfect, but just benchmarks that I'm using. And if we went 90 more degrees, we would go this way. And I have a fairly spatial brain, I think, so this is kind of how I like to do it. I like kind of sketching these out. You can do this in your head, and sometimes I do. Sometimes I draw them out. It depends how smart I'm feeling that day. And once I have this kind of these 90 degrees set out, this is pretty simple, right? I can rotate ABC around point C 90 degrees clockwise. So I know that C to B, instead of going this way, is going to go 90 degrees this way. And again, I'm not going to measure it exactly. I'm not super keen on having you guys do this precisely. So I'm just going to go like this. It's about that long, right? Yeah. And then A goes right across from B. Or we could do the same thing, right? We could draw out our little 90 degrees from A, but I don't want to make this too messy. So I'm going to show you what I would do here. I would just go A and B. It is roughly a right angle right there. So I'd go A to B, roughly a right angle right there. And then I would connect these. And this becomes C prime. This becomes B prime. And this becomes A prime. And you'll notice this triangle is a little bit bigger than this triangle, right? But I'm not really testing you guys or assessing you guys on that part. I just want to know that you can do a fairly accurate rotational transformation. And if we get back to school, which, maybe we will, maybe we won't, then maybe I'll do something a little more precise with you. But right now, I just want to make sure you understand how to do a rotational transformation. Let's try another one here. Oh no, I did it on the wrong layer. All right, there we go. So let's rotate ABCD, rectangle ABCD, 270 degrees counterclockwise around point A. So this is the point we want to use. And we're going counterclockwise. That's important. 270 degrees, also important. So let's see, we would go, this is going to be our 0. We're going to start with A to B. That's the first line I'm going to draw. So A to B would be our 0, and we're going counterclockwise. We're going the other direction. So this would be 90 degrees. This would be 180. Down this way would actually be our 270 counterclockwise. And since this is a long line, or it's supposed to be, I'm just bad at drawing, but we know it's 3 squares long. So this one's not too bad. We can go 1, 2, 3. And this is our B prime. And then B to C is 1, 2, 3, 4. And it's along this line. It's our C prime. D would come up here. And then finally it'd connect back to A. And we'd rename that A prime. So a little easier with a rectangle that's actually on all the lines. But the idea is that you can, as long as you can identify a single line, you can start using the relationships between each point to start drawing out a new shape. Okay, let's try one more here. So rotate triangle ABC 45 degrees clockwise around point B. So here's our point of rotation. We're going clockwise and we're going 45 degrees. This time we're not doing a clean 90 degrees, but that's okay. I'll use the same idea. So let's use A to B as our first one. So A to B, this will be kind of our 0 point. Make a 90 degree ish line. Actually, maybe we'll clean this one up. You can always start with your 180 and then put your 90 degree in between if you want. So A to B, we need to go 45 degrees clockwise, which means we're not actually going to get all the way to 90 degrees here. And 45 degrees is actually halfway in between. So our line is going to go about there. And that's going to be our A. And C will also be here. Actually, I'll do the full lines for C as well this time, just to show you how that might work. So C, we're going to make our 180 line, make our 90 line, 270 line, and C, we're going to go halfway in between there. Then clean these up. Oh, I changed my brush size, excuse me. There we go. Clean these up and finally connect them all. So we'll label our triangle properly. And that would be a 45-degree rotation clockwise of ABC. So hopefully those shapes make sense, or those rotations and those transformations make sense to you guys. Let me know if you have any questions. Have a good rest of the day. Cheers.